Okay, now that we have discussed compound interest, we're going to switch gears and talk about the word annuity. Okay, you may or may not have heard that word before. Maybe you heard it and you don't quite know what it means. So we're going to talk a little bit about the terminology. Okay, first bullet point, it says an annuity is a scheduled sequence of payments. Okay, a really good example of an annuity is a mortgage payment. Okay. If you buy a house, you make it a mortgage, and then you make these equal monthly payments every year over the course of your loan until you pay off your house. Okay. A car note is also an annuity. Okay. You buy a car, you might get a 5-year note, and you make these monthly equal payments to pay off your car. Okay. So it's a regular scheduled sequence of payments. That's all an annuity is. Okay. There's different types of annuities, but in this class, we will only consider ordinary annuities. So what an ordinary annuity is, it's an annuity with equal payments made at the end of regular intervals with the interest compounded at the end of each. Okay, so the key phrase here, equal payments made at the end of regular intervals with the interest compounded at the end of each. Okay, so what we're going to do to try to understand how an annuity works is we are going to repeat example 1, okay, where we took the $1,500. If you remember example 1, we took $1,500 and we deposited it into a bank account, a savings account at Bank of America. The difference with example 1 is you just put in $1,500 and you let it sit there and earn interest over the course of a year. We're going to look at the same problem, same initial deposit of $1,500. We're going to keep the same parameters, meaning the same interest rate, same amount of time. We're still going to, be saving for a year's time. But we're going to look at it from an annuity perspective and map it out just like we did for compound interest in example 1. And we're going to learn how the annuity differs from compound interest. So if you read example 3, it says, what is the final balance of a savings account earning 4.8% interest compounded quarterly if $1,500 is deposited at the end of every 3 months for 1 year? And assume no withdrawals are made. Okay, so if you see this piece of paper, okay, it is the same setup as example 1. Okay, so the only difference, like I said, we've got the same interest rate, okay, 4.8%. We are still looking, we've divided up our year into quarters, okay, so the interest is still going to be compounded quarterly. You're saving for a total amount of time of 1 year. Your initial deposit is $1,500. So all those things are the same from example 1. The only difference now, okay, is you're making regular deposits. Okay, $1,500 is deposited at the end of every 3 months for a year. Okay, so that changes the game. Okay, in example 1, you deposited a one lump sum of $1,500. You put the money in the bank from day 1. You forgot about it. You came back at the end of the year and you figured out how much money you had in the account, and it had grown through interest. Okay, so now you're doing it differently. Okay, you're making regular quarterly deposits of $1,500 into your account. So your money is going to grow not only through the interest, but through those regular deposits. Okay, saving money, regular deposits. That means it's an annuity. Okay, on your formula sheet, there are 2 annuity formulas. Okay, it's gonna be referring to this formula. Okay, this is the one you use for when you're saving money, not this one. We'll talk about this one in section 3.4. Okay, we will visit this formula and how to apply it after we map this problem out. Okay, all right, so let's see how this works. Okay, and again, at any point you can refer back to example 1 to see how the compound interest problem was either the same or different. Okay, all right, so here we go. We've got our our year. It's divided up into quarters. So again, you can think of it just like we did for compound interest. You can think of this line as representing the beginning of the year, so maybe January 1st, and then this is January, February, March. This vertical line is representing the end of March, so March 31st, okay? April, May, June, okay? This vertical line, end of June, June 30th, okay? July, August, September. This vertical line, end of September. October, November, December. This is December 31st, end of the year, okay? All right, so let's get started, okay? So this is an annuity. The first thing you've got to do is open your account and make your initial deposit. Okay, now you got to be careful here. We said that we are only studying ordinary annuities. Okay, so you're making equal payments. Okay, we know that each of our payments is going to be $1,500. But the key here for mapping this out, the deposits are always made at the end of the intervals. Okay, so you don't deposit the money on the first day, okay? Technically, theoretically, it's supposed to be made at the end of the first quarter, okay? So on January 1, theoretically, nothing happens. You wait for that first quarter to pass. So I'm even going to write here, nothing happens. Boo, okay? So you're going to wait for that first quarter to pass. So January, February, March 31st rolls around, the end of the first quarter of the year. That's when you make your first deposit of $1,500, okay? And then that money just sits there through the second quarter, okay? So April, May, June are going to pass. And then at the end of the second quarter, that's when you're going to get your first interest payment. Okay, I know this seems a little weird, okay, but everything is done at the end of each quarter, okay? Everything is done at the end of the time interval. At the end of each time interval with annuities, two things happen. You calculate the interest and you make another deposit, okay? All right, so June 30th, end of the second quarter, okay? Let's go ahead. You're going to get an interest payment, okay? So remember, interest, okay, you're going to use simple interest when you're mapping it out. So principal times rate times time, okay? So far we've had $1,500 sitting in the account. The interest rate is 4.8%. And this money sat in the account for 3 months, April, May, and June. Okay, so the time value is going to be 3 out of 12 months. Okay, so if you go ahead and you take your calculator and you compute the amount of interest this is going to give you, I think it's actually the same thing that we experienced with compound interest the first time around. So it's 1,500 times 0.048 times 3 out of 12. You should get $18. Okay, so that's how much money or how much interest is earned from this first $1,500 deposit, okay? So at the end of the second quarter, okay, you're going to have your total account balance is going to be the $1,500 that you've had in there, plus the $18 worth of interest that was accrued over April, May, and June. But now, this is the end of a quarter, you have to make another deposit. So we're going to tack on, this was the initial $1,500. This was the interest that $1,500 earned. Now you're going to make another deposit of $1,500. So on June 30th, you have a total of $3,018 in the account. Okay, so it's a little bit different here. Okay, I'm going to box the account balance at the end of each quarter there. Okay, so again, this was the initial $1,500 that was deposited over here. Okay, it earned interest over April, May, and June. Okay, we calculated that interest using the simple interest formula. That was 18 bucks. Okay, so initial $1,500 plus the $18 worth of interest. At the end of the quarter, you have to make another regular deposit of $1,500. So you end up with, on June 30th, a total of $3,018. Okay, so now this amount sits in the account. Okay, $3,018. Okay, it is going to sit in the account over July, August, and September and earn interest. Okay, so September 30th, the end of the third quarter rolls around. It is time to do the two things. You need to calculate the interest that has been earned over the quarter and make another deposit. Okay, so let's calculate our interest. Okay, so principal times the rate times the time. $3,018 has been sitting in the account over this quarter, this third quarter, okay? The rate is 0.048, okay? It sat in there July, August, September, so 3 out of 12 months, okay? So you can go ahead and figure out what that's going to be. Okay, let's plug it into the calculator, okay? So we will get, let's see, we will get $3,018 times 0.048 times 3 out of 12. Okay, so this is going to be $36, and you need to go ahead and round this to the nearest cent. And so you look at, you've got 21 cents, you need to look at the 6. If it's 5, 6, 7, 8, or 9, you need to round up. So this is going to be $36.22 worth of interest that has been earned in the third quarter. Okay, so at the end of September, the end of the third quarter, okay, figure out your balance. So you need to take how much you started with, the $3,018, tack on the interest you earned during the third quarter, so $36.22, and you need to make another $1,500 deposit. Okay, so let's figure that out. Okay, what does this add up to? Okay, so we're going to do $3,018 plus the $36.22 worth of interest plus another $1,500 deposit. Okay, so at the end of quarter 3, you have a total of $4,554.22. Okay, all right. Now, this amount of money is going to sit in the account for the remaining quarter of the year, okay, because you have to go all the way to December 31st, okay? All right, so this amount will sit in the account October, November, December, okay? December 31st rolls around, we need to calculate our interest, okay? So PRT, actually, let me move a little higher so I have enough room. Okay, so I is PRT, okay, so it's going to be the amount that's been sitting in there, so $4,554.22 times the rate times the time. Again, it's been in there for the fourth quarter, which is a 3-month period. Okay, so plug and chug this into your calculator. Okay, we're going to get that this is, let's see, let's type it in. So $4,554.22 times the interest rate times the time. Okay, there we go. We get this crazy number. Round appropriately. So you've got 65 cents here. Look at the number after, which is a 0. Since it's 0, you're going to keep it at 65. You won't round up to 66. So that's going to be $54.65 worth of interest. Okay, so then to get your account balance, okay, you need to take what you started with, the $4,554.22. You need to add the interest that was accrued in the fourth quarter, which is the $54.65. And even though this is the last day of the year, it is the end of the quarter. So theoretically, you're supposed to tack on another $1,500. Okay, so let's add this up. And we get a grand total. Our balance after 1 year is $6,108.87. Okay, so that's how much we have in the account after 1 year. Okay, and you can see it's a whole lot more than we got through compound interest. Okay, remember, we had the same exact parameters in example 1. The only difference is we didn't make regular deposits. We only put in one lump sum of $1,500 on January 1st, and we let it sit there and earn interest. So you can see this is the amount in the account after 1 year using compound interest. And if you make those regular deposits, you can see you get a lot more money in your account because you're contributing more money, and then there's more money in there to earn interest. So you definitely get a bigger number. Okay. All right. So, like I said, this gets tedious. Okay. We know that from compound interest. Every time you map something out, whether it's compound interest or an annuity, it gets tedious. okay? You don't want to have to do this if you had a situation like you were saving for 25 years and you were compounding monthly, okay? Don't want to do that, okay? That's why these formulas exist, okay? So let's rework example 3 using the formula for the future value of an annuity, okay? So again, if you take out your formula sheet, okay, I explained this in the beginning of this section, okay? Under annuities, you have 2 formulas. This is the one you want to use for saving money, okay, where you're making regular deposits. This formula is used for annuities, but in a different situation, and we will get to that in section 3.4. So this is called the future value of an annuity formula, and that's what we want to use here where we're saving money, okay? So let's go ahead. I'm going to write that formula down, okay? It is definitely more complicated than the compound interest formula, okay? But you do see the same variables, which is good, and they pretty much have the same meaning, okay? So let's talk about that really quick, okay? And then we'll plug and chug, and we should get the same answer we got through mapping the problem out, okay? All right, so when you're working with this formula, okay, R is, of course, the interest rate, okay? And like I've told you before, has to be a decimal when you plug into the formula, okay? M has the same meaning that it did for compound interest. It is the number of compoundings per year. Okay, so it is how many times per year the interest is being added to the account. Okay, it is also equal to the number of deposits per year. Okay, so if you get a problem like this with an annuity, okay, you're going to see a phrase like compounded monthly, okay? So if you see an annuity problem that says compounded monthly, that means the interest is being added to the account 12 times a year. It's being added monthly. If you read the rest of the problem, it should also say that you're making monthly deposits. How often you're making deposits should coincide with how often the interest is being compounded. Okay, those two things should always match. They will never differ. Okay. All right, T is going to be the time in years. And then P is going to be, remember with compound interest, it was the amount of the one lump sum. Well, here it is going to be the amount of each deposit because you're making those regular deposits. So P is going to represent the amount of each deposit. Okay. And then A is going to be the account balance. Okay. So these variables pretty much mean the same thing that they did in compound interest. Okay. All right. So for example 3, okay, let's go ahead and plug everything in. Okay. So we were looking for our account balance. Okay. Our P value is the amount of each deposit. Each regular deposit was $1,500. Okay. Inside the brackets in the numerator, you're going to have 1 plus the R value. Here's the interest rate as a decimal divided by M. Okay. Remember, everything was done quarterly here. Okay. Every quarter you tacked on the interest from the previous quarter, and you also added a new deposit. Okay, you made another deposit. So everything was quarterly here. So that's 4 times a year. Okay. So M is 4. So the exponent's going to be 4 times T. We saved money for 1 year. So that was the T value. Okay. Outside of this, now you need to subtract 1 in the numerator. So I'm just following the formula. Okay, so now in the denominator, you're going to have the R value divided by the M value. So that's how you would set this problem up. Okay, so now we're just going to plug and chug this guy into the calculator. Okay, so let me get my calculator. All right, so this formula, like I've said already, much more complicated than the compound interest formula. So you may be wondering how to plug this in. Okay, so what you're going to do here, okay, we're going to start with the most complicated part, okay? That is definitely inside the brackets, okay? You've got 1,500 times all this junk in parentheses, or sorry, in brackets. we are going to start in the brackets. It just looks more complicated. And then if you had a choice between the numerator and the denominator, the numerator looks more complicated. So we're going to start there. Okay, so I'm going to start in the numerator. So just watch what I do. I'm entering it in just like I see it. So in parentheses, I've got 1 plus 0.048 divided by 4, close the parentheses. Either do the exponent in your head, which you can do here, it's 4. If the exponent's more complicated, you need to put it in parentheses. Okay, close the parentheses before you subtract 1. This is the numerator, so hit enter. Okay, that's a nasty decimal. Okay, so then you need to divide it, so hit the division key, by the denominator. The denominator, put it in parentheses if you have an older calculator, just to be sure. Okay, so 0.048 divided by 4, close the parentheses, hit enter. This is going to be the quantity in brackets. Okay, and then you need to take the result and multiply it by 1500. So I'm going to do times, it's going to take my previous answer, this decimal, and multiply by 1500. That's going to give me the account balance. Okay, so let me go ahead and write this number out, and then we'll talk rounding. Okay, all right, so remember, account balance has to be dollars and cents. Okay, so we've got $6,108, and then we've got 86 cents. Okay, you need to look at the number after the 86 cents. Since it's a 6, you need to round up to 87 cents. Okay, so that is your account balance that you've obtained from using the formula, and you should notice it's exactly what we got when we mapped it out in example 3. All right, so now what we're going to do is we're going to move on to example 5. Okay, before we start working these types of problems out, whether it's compound interest or the future value of an annuity, I want to give you examples to read through just so that you can identify whether or not you're dealing with a compound interest problem or the future value of an annuity problem. Okay, and then once you learn how to identify each problem as one type or the other, then we will spend some time working through them.